Hello, everybody.
Hello.
Rohit will be here shortly. I was just talking with him in another meeting, so he'll be along in a minute to take over. But any questions anybody has before we get started? How's it going? Anybody stuck or lost? I mean, too far. I expect you to be a little lost.
I have a question, but it's not. It's about like the training of Tetris to predict the thing, like the capacity, like the instruction that it was given that you sent an email in. I have a question about that. I don't know.
What's your question about that so far?
My question is like, it seems like it's as the systems that work with the I don't know, like the flow of the water is more historical. How real time can we get, or is there a way to intercept that data that we know or we can predict? Because all the examples I saw, it was kind of like examples that things that happen, and you kind of gotta interpret the graph in order to make a consensus, kind of like that. I'm trying to see in a way that I can maybe like intercept that data maybe and get like a notification system working, but I'm playing with it. So I guess I just need to probably understand a little bit better, maybe like what is like a good marker of a possible flood in what areas.
Yeah, actually, there's some other things that are newer that probably would answer that question better. Let me just bring up a forecast just for an example. So there are two things that happen, two primary things that happen when we access the information on a stream. One is the current forecast. Okay, so this, although this one starts at May 11th, yesterday, so the current forecast isn't up to date. We're almost usually a day behind just because of the way that the whole computations work. So, but starting May 11th, then it goes out to May 21st. So it's plotting 10 days. There's actually 15 days worth of data, but we only plot the first 10 days. So this is a forecast. And if it goes up into these colors, it indicates an extreme flow, right? So that's when you trigger a warning. And so that is into the future 10 days, basically what you're getting. Of course, the historical analysis is what tells us whether a forecast is extreme or not. Because if we look at what happened in the past, we can see the worst floods here. And so we know what a large flow rate means, right? Because otherwise, if we didn't have the historical data, then we'd just see how much it is, but we wouldn't know if that was rare or common.
So how if it's rare, would it, like, let's say if I create a system that notifies if there's a forecast in the 15 days that it is, would it be like how much historical data versus kind of like the rare occurrence I need to consider to make like an assessment? So if it's rare, maybe it's like, well, just notify and maybe have more checks to verify that is not just like a bug or stuff.
That's subjective, right? So some places, if it gets up in the yellow or orange, it might begin to flood a little bit. Other places, it could come clear up here in the purple and it would still probably stay in the river and it wouldn't impact anything. One of the things that we're doing on our current project is actually converting that to, I'm going to try to bring up another picture here. Convert that to a flood map, because honestly, this graph shows, is important to a hydrologist, but not to somebody that hasn't studied hydrology, right? Or that needs to make a decision. So what we're really trying to do is get to a flood map.
Mhm.
That would tell you, okay, if I can see it as a map, then I would know whether it floods homes or agriculture or what kind of a flooding event that is.
Mhm. Okay. Hmm.
I don't know why my PowerPoint doesn't want to launch. I think it updated it. So I can't show the picture I wanted to show you, but maybe. Rohit, when you get on, let me know. Por Jim Nelson de queremos expandir. Se puede utilizar. Okay, Daniel, this one,
Mhm.
this kind of shows the idea of if we, what we
Mhm.
really want to do is take the stream flow and convert it to a depth of water
Mhm.
on the ground, which then will tell us where it floods and who gets flooded, right?
Mhm.
And again, depending on, in some places, it doesn't take very much water. It depends on the banks of the river and how it gets flooded. Others, it takes more. That's why going to a flood map that shows us who gets flooded, how deep it is, and what is there will be a lot more interesting, right? The
Mhm.
whole idea of social media would be to try to incorporate people that are using Twitter or WhatsApp. If there's an API, I don't know
Oh,
how.
there is Twitter. I've been researching in all the social media. So it's Twitter, WhatsApp. WhatsApp is really popular. We can even register as a business or nonprofit organization, and we can get even branded and stuff. So we can even have like a marketing, like text this number about a flood or send a photo or something like that.
That's right. So that idea would be to combine that information with what we're modeling. Obviously, you can't get, social media data forecasted 10 days in advance.
Yeah, of course.
But anyway, so that's kind of the idea for incorporating social media. And I think that if you've had a chance to look at some of this, what I wanted to do is maybe arrange a meeting with you and Dr. Hughes about, and let's discuss that more, okay?
That will be great. Like that will be great because I'm looking how to incorporate and how to quantify in order to like make a service that can track that or understand the logic, like what steps I need to do to get that information.
Okay.
Yeah.
Hey, Rohit, I see you're on now. So I'm
Yep.
going to turn the time over to you. And this is the first time of doing this. It's kind of, I don't really have a formal idea, but I kind of thought you could bring up the Google Doc that kind of outlines and just see what questions there are and kind of maybe assess if people learned what you expected them to. And please, everybody, take advantage of Rohit being here. If you have questions, be sure and ask him, things that aren't sure. There are no bad questions at this point, okay?
Yeah, there aren't. So I see there's a bunch of people on, but I can't see anyone, but that's fine. So my name is Rohit, as it has been mentioned. I've been with this lab forever, it seems like.
You
20
have 2 stints.
Yeah, so I did my master's first in 2013, 14, and then I started my PhD in 2018. In the middle, for 3 years, I worked for the church in Riverton in their software ICS department. So that takes care of their main websites and stuff. And I was in charge of backend for LDS.org. So there might have been a few times that it went down because of me, and that was fun.
Church of Jesus
I
Christ.
like programming. Yeah, sorry, they changed that after I left. So, but yeah, I like programming. I've always kind of programmed for, even if I didn't have to. I try to code my homework up just because I like to code. I'm mostly familiar with, these days, with JavaScript and Python and Node.js, backend server technologies. I have done PHP in the past for quite a bit of time. And yeah, that's one day I hope to graduate. I'm in my, third year? Yeah, third year of my PhD right now. So hopefully that'll land one day. But yeah, that's about me. I don't know if any of you guys would want to, probably this will get boring if we do it every time. But if we do end up discussing something, you can introduce yourself a little bit, just so that I know what kind of programming background you guys have, and so that we can, discuss in those terms, to be exact. So system operations, I'm just going to give a brief overview of what this was, and then we can just go through each section and see if there are any questions or concerns, or if there were things that I really wanted to point out, and I just want to make sure that point has been clearly communicated. So the first thing is to mention is that this is no way a comprehensive guide of system operations. There's actually a whole class that the IT department teaches in system operations. This is a 500 level course. And even that's not sufficient at all. System operations people have been working in just doing system operations for 20, 30 years. So people have a ton of experience there. But the knowledge that's provided over here and the topics that we cover are things you will commonly come across in the lab once you start getting into some deeper stuff. And so you might have use of one or maybe all of these things that you've gone through in this document. I just feel like it's better to give you this introduction up front, so that when you do have to face these things, you're not like just confused about, hey, where do I go from here? You have some idea, you've practiced some things, and there are tools that you go through in this document that tell you how to look for other things if you can't find that these commands do what you need to do. So that's kind of the introduction, is that you'll be using command line or terminal. I can share my screen at any time, and we can go through the terminal commands if there were any questions or doubts over there. As recommended, use a macOS operating system, or you could use this online shell. I don't know if anybody tried using this shell or had any issues with that. Was it all good? Does everybody have a Mac OS that they use?
I don't, but I used the shell and it worked really well.
Okay, perfect. So yeah, the shell will work, like this one should work pretty much similar to what you have on your local machine. So this was initially 1 to 2 hours, but by the time I finished writing this, it became 2 to 3. I don't know how long would you say at an average it took for you guys to finish this?
I think for me it was maybe 2. I can't remember. It was about a week ago I did it.
Okay. So a week ago we were missing the last 2 sections, I think. So 2 is
Okay.
a good estimate. Yeah.
Yeah, I think
I
you
guess
could.
I'll leave that at 2.
Sorry, I think you could easily spend a couple hours, like at least 3 hours on it.
Oh, okay.
Yeah.
So let's move that to 3 to 4 just to be safe. Okay. So basically, there were 5 different concepts that I wanted to explore in this tutorial. The first one was just what Linux is, what does it stand for? Because oftentimes we've used either a Windows machine or a Mac OS, and so we don't really know what, or we hear the word Linux, it's like, oh, used by hackers. And that's not entirely true. I mean, Linux is just an open source operating system, so it's very common. Almost every device that you have, every smart device that you run, if you have a Google Home, if you are running an Android phone, if you are like have a smart device, a smartwatch, all of these run on some flavor of Linux, and they're built on top of it. So at the core of all of these things, Linux is running. And what Linux is basically an operating system. So so in your Zoom, there's an option of raise hand. So if at any time I'm going through something that's not really clear, just push that button so we can go over that concept or answer any questions that you might have. Linux is basically an operating system. What is an operating system? It's basically something that your computer runs so that you can communicate with the hardware that's inside it, because as we all know, computers run in bits and bytes, so zeros and ones. It doesn't really understand words, or it doesn't really understand commands that we give it directly without something in the middle that translates that for us. And so that's what kind of the operating system is. Over the years, it has become a lot more than just a basic translator, but at the end of the day, everything does have to be turned down into code that your hardware understands. And that's kind of the job of the operating system to do that. As we go through this, we can see that there is various types of operating system. Linux occupies a huge market share. And that's basically the language that a lot of servers run in as well. You might have heard the word Ubuntu used a lot with Linux. Usually Ubuntu is one of the most common Linux distros. And if you don't know what distros are, then you haven't gone through this. So you can go through that. Then one thing to consider is this one, not all Linux distros will have user interface. So like this, basically my screen right now this is a user interface. Like this, if all these folders, all the ability I have to click here and do things with that, it's all coming because someone sat there and designed the entire UI so that it looks this way, it appears this way. The tabs appear like this. When you hover over them, they highlight. All of this was written by someone. But however, when you work with servers and oftentimes working with Tethys, you will not necessarily have access to a user interface. When we connect to a server, you might not see a user interface there. And in that case, we use something called the terminal. And so we've all seen some examples of my terminal because I've put screenshots of those. But that's kind of what my terminal looks like when I start it up. Terminal is basically a way for us to give direct commands to the system, and it will process it without us having to click on anything or move anything. I can do the same thing that I would do in a terminal with my user interface, but a terminal can do a lot more as well that you can't really do things using a user interface. One of the best things about it is the commands that you run on the terminal. Each one of them has a manual page. And this is something that I kind of pointed out in our Bash Basics section, is that at any point, so one of the commands we saw was ls. And at any point, if we want to figure out what more can we do with ls, we can just do man ls, and it gives us a nice little description of, okay, this is what this command does. Each one of this is called a flag, and you can specify one or multiple flags to affect the behavior of the core command. And this is just a very simple example of using ls. These commands can get pretty complicated depending on what you're trying to exactly do. But luckily, for most normal day users, you won't have to get into that much. And if you even do, like, honestly, you can always Google man ls as well. And there is this website called man7. that actually has the same copy of the ls page that you had in your terminal, but it's just that you can access it in a web format instead of trying to scroll through your terminal and read every line. Over here, it's a little bit better highlighted, and just you can search through this and find what options you're looking for. And that's generally what I do as well. So it's not like anybody expects you to memorize all of these commands, but just kind of having an idea of what command to use in which place would give you a huge benefit, because then you can look for that specific thing instead of just wondering what command should I type. It's better to search what modifier should I put on ls for it to display this than what command should I type to display this, because then there's about 100 ways to do the same exact thing in terminal, but we want to choose the most direct, most efficient option in that case. So we all went through this, I hope, where you can open a shell. This is kind of how it might look on your screen without any modifications. Mine has a few colors changed and other things, so it looks a little matrixy, kind of what I was going for. Then we discussed about this, that each command has set of options and arguments. So when we were doing cd, and I said, hey, I want to go back one level, cd is my command, while the ... is my argument. I haven't provided any options here. So like if I was doing an ls, the /a or -a, -l or -h, these are options because they all start with a dash. You might see options also start with double dashes at times, and that's okay. I don't know if ls has any, but some other commands do, and that's fine. We also saw that if you want to provide multiple flags, instead of doing this, you can just combine them into one. It will have the same exact effect. And so it'll work in the same exact way. So every command will have the same structure. And then this talks about using the man page and how you would do that. Then we explored some common, actually any questions so far, any concerns, doubts, things that felt like they weren't clear enough. Because as English is not my first language, so writing this I could not be clear. There might be places where I'm not very clear in what I'm trying to say. And so we're looking for improvements. So if you have any, you can leave comments on the document, or you can tell me now, and then we can make a note of that. Is there no questions? I'm just kidding. Sorry.
Could you maybe give some examples of just like how you use the terminal in like the lab, or like how it's applicable for us?
Yeah, sure. So we can do a very quick demo. So I am currently, so one of the words you might have heard on the lab is called tethys, which you will learn about eventually, not eventually, pretty soon in our training. But the idea is that tethys is basically a tool we use to create a bunch of different apps. Now, when we do that, when we do the creation of these apps, and oftentimes we will use the terminal to create those. So for example, I want to create a brand new app. In tethys, there are commands, and I wouldn't worry about right now remembering those commands because you will go through that. But I can just go to my tethys environment, and I can ask tethys to create a new app for me. Now this command that I'm typing is very specific to tethys, and that's why it works. And if I just do that, what it's going to do is, oh, it requires a name. Okay, so let's call it hydro test. And what this is going to do is try ask me some questions, and basically, depending on what I enter, it's going to try and create a very base level app. It's just empty. It doesn't really have anything right now. So I did all of this. I could have done this using the user interface by copying each file, renaming it. But now I have a nice little template for my app that I can use. Now, again, I wouldn't say you have to worry about exactly what happened in there. It's just the idea that you can use terminal. Then for managing tethys, for doing everything tethys, you kind of will use the terminal. So for example, I did create that app but now I want to include that app within my Tethys installation. So I already have Tethys installed on my system. You would do that eventually when you go through the Tethys training. But as you can see, I'm using a common command. We went through CD. I'm like, okay, let's look through the directories. Then there is another command called Tethys install, which in this case, again, you don't need to worry about for now, but the same thing. So what this is doing is basically taking that app and installing it onto my portal. And all I had to do was type that command in my terminal. So that's one other place that you see terminal being useful to you. Something. Let's see if it gets. Anyways, let's assume it got installed. And then there is another command that is itself. And as you see, all of these commands are being typed in a terminal. So when you do that, when we install Tethys, we install the language that listens for these commands. And it's like, okay, great. When, I wonder if, oh, that's why it's already running. But yeah, so we installed Tethys. And now if I do this, so this is running on my local system. But just by running that command, oh, I guess it couldn't bind. Let's try that again. Oh, something I forgot to include in this document, and I guess I should point out, is at times you're running a task, as you can see now, so this is your normal command line. Let's go here, where you have an arrow and you can type any commands in there, and they will actually make a difference. Here you see there is no arrow available at this time. This is because there is a process that is running that has taken over your terminal. And if you ever get stuck in a situation like this, to get out of it, you press Control-C. And it's most of them will give you hints about what you need to do to exit from it. But if you just do Control-C, that will quit from that program. But yeah, so yeah, this sets up my Tethys portal, and you can see it's running up locally. So that was just a very quick example of how we use terminal on a daily basis to run our local Tethys portal, so we can develop apps on it. And then once the apps are developed, they're moved to a live server. They get copied over and installed over there. Sorry, that was a very roundabout way of answering your question. Does that kind of give an idea, though? It's like, this is kind of the common tasks you'll be doing using a terminal. There are some like Tethys manage start you can't do without using a terminal. There's no other way to do it. But then there are some like the copy commands and installing a new app, you could do it manually as well. Okay, so let me get back to this guy. We went through 3 very basic commands that you will utilize all the time. So pwd is pretty straightforward, tells you what your current directory is. Is there any questions on understanding what a directory or a folder is? Because I use those words interchangeably, but it's, I think, essential to understand that whenever you're in a terminal,
did you show an example in your, if you were to bring up your Finder window, for example, that you can show the user interface to the same structure you're looking at here on terminal?
Yeah. So if we just look at this directory, that's a good idea. I'll include this comparison as well. But as you can see on my screen right now is, I'm in this directory, and let's do ls lh. You can see the same exact files. So the build, dist. How do you differentiate files from folders in when you do ls? Well, very simple. The folders won't have an extension in front of it. Each file will. So that's one way to differentiate between the two. But you can see that this has the same exact structure as I do in my Finder window. So I could use my Finder window and say, hey, I don't want this to be installed. I just want it to be installed too. And now when I go here and do lslh, I can see, okay, yeah, it's the same directory, the same file was changed. However, I could do the same exact thing with my command line by using the move command. and saying, hey, I want this to be renamed back. Now, if you notice, both in my Finder as well as in my terminal, the file actually gets renamed. So that's just a way to say, yes, you can do this, similar things, or some of the things that you can do in a terminal here.
It
But
also emphasizes the point Rohit made earlier that every user interface that you've used on a computer really is just a user interface. Underneath it is running the operating system like Unix or Linux that he's showing, right? And so
Yep.
all the terminal window is bypassing that user interface, but doing almost all the same kinds of things.
because basically when you are issuing a rename command from here, for Mac users, it's so simple. You like, oh, press return, type in the new name. In the background, the user interface is doing the same exact thing. Is it's taking the action that you did and converting it into a terminal command or a command for the system. And then it's just running that and getting the result back and showing us the new updated result. And that's kind of how almost all UIs work, is they have a thing called a kernel sitting in between them and the system, and they just issues commands to the kernel, and the kernel interacts with the hardware that way. But yeah, so we went through a few commands, ls, cd, and pwd. Any questions about these three, or any issues that you guys had while looking through this section? Well, I guess I wrote it really well. Okay, so we can skip it. The one thing I wanted to point out was the H flag. It's useful almost everywhere. So over here, as you can see, the sizes don't really, so this one shows up in, I don't even know what. It should be bytes by default, but it doesn't even show that symbol.
It is bytes.
Yeah, but that's what I'm saying. Like when you do, I mean, I guess what I meant was I knew what it was showing. I was just like, when you do this, it does not convey enough information to tell you what it is. Or if it was a big enough file, you wouldn't be able to even see it properly. So if I was to so habitual to typing that, but yeah, it's like 9065. Well, that doesn't help me. It just doesn't give me any information about how many bytes or kilobytes it is. And that's why the H tag helps us, is because it actually converts it. The other point of warning that I had mentioned in the document is do not trust the size for a directory, because it's not true. It's only for a specific file. So like this file, for example, app.txt, it's 8.9 kilobytes and I can trust that. However, this is a directory called applications. It's not 192 bytes for sure. It's a lot more than that. And ls doesn't go deep into your folder structure and finds out the size of each file. I'm not sure if I did mention the du command, and you can always use du, but as I said, like with the h tag works with everything. So let's try du without the h tag. And if I just say, give me the size of, just give me the size of everything in here. So this shows that the applications directory is some 100,000 bytes. But again, that doesn't give us a lot of information. It doesn't help us a lot. So we can, same way, use the H tag that we use with ls. So H is pretty universal with what it does for most commands. But when I do that, at this point, it tells me, okay, your applications is 55 megs and your other libraries are 143. So it gives a much better estimate. And at this point, as you notice, it's taking a while to run this because it's going through each directory and trying to calculate the size of each folder that it finds. Some directories it will not be able to get into because it doesn't have the right permissions. Yeah. I don't know if I mentioned this. I don't think I did, but there's always a clear command that you can type in your terminal, and that will just empty it out and start fresh. Or if you have something on your terminal, you can do Command K on a Mac, and that will clear it as well. So you can either type clear or use Command K, and that should help if you just want a cleaner terminal screen. Then we talked about CD real quick, and basically CD is just for changing directories. So whenever you are in a terminal, it kind of tells you where you are with respect to your home directory. So this tilde sign right here stands for your home directory. And then it's like, okay, you're from your home, you're on your desktop. Now, if I wanted to go into my folder research, I can just do CD research. I can type the whole thing, or I can type the first 3 characters. And this is something I also wanted to point out, which I've done in the docs, but doing a lowercase res will not work, will not actually complete it. If I do a large case, the correct case, it'll actually complete the whole term, and then I can just do enter, and it will actually change it. So folder names are case sensitive in your terminal, so you got to be careful about that. Is sometimes you might need to copy a path from somewhere to other and make sure that the case matches, and that's pretty important. So yeah, but CD commands can be changed. So let's say I wanted to go, let's say I want to go into my research folder, and then I wanted to go into Tethys, and then I wanted to go into, let's see, what else is there in Tethys? This Docker directory. So now I'm 4 levels down. I'm in desktop, research, Tethys, Docker. So if I open this in my Finder, you see some of the files over there. I can tell my Finder to go up 1 level, and it brings me back to the Tethys directory, 2 levels, 3 levels, and I'm back on my desktop. We can do the same thing in our terminal as well, just by chaining command. So this by default will take you up 1 level, or if you do it 2 times more, it can take you up 3 levels. So we're back on desktop, and you can see that over here. That'll show you your current path of the system that you're on. So that's basically CD. We talked about make, dir, and cat. Cat is pretty useful. Make, dir is pretty straightforward. It allows you to create directories. Make, dir will throw an error. If, for example, let's see, there's already a head directory called Hydro-test. So if I try to recreate it, it will actually throw an error saying that file already exists. Once again, there are always flags that you can use. So you can use the -b flag, which says, hey, create this directory if it doesn't exist. Again, as I said, I don't expect you to remember these. I'm just saying there are always options to modify the commands that you commonly use to kind of make them do what you want them to do exactly. We looked at curl real quick, but we didn't go into a lot of deep details. But curl is just basically, it can take a URL. So it can be a web page, it can be a document, a video, whatever it is, and then download all of that into a file, which in this example, we downloaded it to just a text file. And then we did a bunch of things with those text files. We talked about how cat can be used, how head and tail can be used. And then finally, we looked at a few commands that will help you just manipulate your files. So move, there isn't a rename command, so you kind of have to move something to rename it. And then there's also a copy command that we can use to copy files. We can also use copy to copy entire directories, but that's, so this is now empty. CD. I'm just going to create a couple of files in here. Now we can see we have this directory called Hydro-test, and we have 3 files in it. So let me go back to my desktop, and I can say, hey, copy Hydro-test to Hydro-test 2. And as soon as I do that, you see that I get an error saying, hey, you specified a directory, but I can only copy files. Well, not so much, because there's a modifier that you can put on copy and say -r, which is just saying recursive copy. And so what that does is goes through the directory, looks for each file and copies it. And if I do that, as you can see, I don't get an error. And when I look at my files this time, I can see I have a hydrotest2 directory. And I can go into that and see that I have those 3 exact files that I had in the other one. So that's just an example of how to use copy to copy a whole directory. I should probably add one over here as well. But just to point out that you can always use the basic commands that we've learned and modify them to suit your purpose. Removing this one, be very careful, and I've mentioned it over here. It actually deletes the files from your file system. It doesn't go to your recycle bin or your trash can. It just goes away. That's, you can't recover it. So if you ever do remove, you have to be very careful. One of the things that you have to be most careful about is when you're removing a whole directory. So let's see, I want to remove a file templog.txt. That's fine. It just goes ahead and deletes that specific file. But if I wanted to delete everything in this directory and everything below it, again, I have a modifier called -r, and I can do, okay, delete this. So at this point, if you notice, it went ahead and deleted the entire hydrotest2 directory. However, there's no way for me to recover it. There is no way where I can find it in my recycle bin. It doesn't exist. There is no undo command. So if you ever do remove -r, be very careful. There are jokes that you'll find on the internet that might tell you to type this in your command line. If you ever do that, this is basically issuing a command saying, delete everything from my system, starting at the root level. So at the topmost level of my directory. So it's basically going to delete everything, and you can't recover it. So just be careful when you use remove commands, especially if you're copying something from the internet and trying to run that because you were stuck somewhere. Just be very careful. Okay, any questions so far about command line basics? Or any suggestions for the course that we can improve on? Any areas that you found problematic? Nope. Okay. So let's talk about Secure Shell SSH. Secure Shell is pretty useful because, for example, if you go to tethys.byu.edu, this is running a Tethys portal with all of these apps installed on there. Now, there are times when I have to get in, or someone has to get in and change the app. Like, for example, this is called Crazy Search. We might want to install a version of the app that's called Hydro Explorer or something else. Or this image is missing. We might want to fix the image. So just minor things like that are some of the parts of the things that you'll do in terms of server management. And for that, you need to know how to connect to a server, because these are machines that are somewhere in the Y-Cloud servers in the library across the campus. You never have actual access to the physical machine, so you can't see the CPU or the box that's controlling the hardware. However, you have SSH access, which means you can open a terminal that's inside this machine. So just as an example, over here, we went through an example and connected to a training server that I found. That's just so that I could put this username and password in this public document, because it doesn't really matter what you do on there. You can delete everything. It doesn't make a difference. However, most of the times what you will do is you'll connect to an SSH server. So for example, you'll provide your username. So you say username at whatever is the server address. So in our case, just as a demo, I'm going to try and connect to our main tethys.byu server. Remember the password. Wait, this might be. Okay. Try connecting to a different one. Oh, that one worked. So in this case, since I'd already logged into the server, there's a way to save your credential information, and that's a little bit advanced, so I didn't go into that over here. But basically, it knows who I am, so it will let me in. And so now if you notice, instead of saying on a normal terminal where it says, you're a desktop at my local MacBook, and it allows you to type commands, it says you're civil at data staging. So this is one of the clear indications that you're connected to a server and you're working on that. As we've seen, most of the commands that we've already seen will work on this. So in here, you can see a bunch of different things that are installed for this specific server. If I go to yeah, so this is like the list of apps that have been installed on this server already. And basically, we can go through each of them and update them or do whatever changes we wanted to. But this shows you that you're on an SSH server, you're on a different server that is not really connected to, which you're not sitting on the machine, but you're just connecting from your terminal to their terminal. And that's kind of why knowing terminals or bash commands is useful, is because oftentimes when you connect to a server, you won't get access to a user interface. You will just have access to a shell. Anytime you're done with your work, you just say exit, and it will say, okay, I logged out, connection to my server is closed, and I'll show you now you're back on your machine. So now if you do LS, you'll see a bunch of different things because it's just connected to your machine. So that's about it for SSH. Cron jobs was a section that I marked as optional, is because there might be a time where you have to use it. I don't think everybody gets to really use it. The other reason I marked it as optional is currently the training exercise doesn't work well on macOS. There are permission issues that at least I faced on my system trying to get it to run completely. So we need to rework the training exercise. But overall, just the quick overview of what a cron job is just allowing us to repeat tasks every so often on our computer. There is a program called cron that contains a list of these commands and the duration on how often we want to run this. So actually, let's SSH back into our machine and see if there are any cron jobs. Okay, so this is on our server. In one of our servers, you can see there's a few different cron jobs that are set up. And basically, the first 5 characters, these are telling it how often it needs to run. So what this one is saying, as we can understand from here, is the first position is for minutes, the second is for hours, third for day, month, and then day of the week. When you put a star in one of those positions, you say run it for every instance of that position. So in this case, a star over here means this is run every day of the week, every month, then every day of the month, followed by every day at 3 a.m. This is specifically saying only at 3 a.m. every day run this. And this just says this at the start of 3 a.m. it's going to run this. This one is saying at 3:45 you're going to run this every day, every month, every week, whatever else. Install. This is a special modifier. So instead of using these 5 things, we can just use something like at reboot, and there are more of these. And what this does is say, okay, you're going to run this command. In this case, you can see there's a script that's being run. You can also put in a direct command that is from the terminal bash terminology. And in this case, it says, okay, every time this is reboot, you're gonna try and make a new directory, and you're gonna do something else. I mean, let's not go into the command, but basically this is kind of how a cron tab looks like. So cron tab is just a listing of the cron jobs, and these will run according to its schedule on the server. We can also do cron tab -L, or which in this case says no, there are no cron tabs for me, but if I do sudo cron tab L, it tells me what cron tabs are installed for the system. We didn't really go over sudo through our tutorial, which I feel like I need to add, so I will make a note of that. But sudo is basically taking extra privileges to do things that you're normally not allowed to do. I'll most of the time try avoid using sudo unless you're working on a production system where you absolutely need to. For your local systems and for other things, you shouldn't need sudo. Sudo just basically grants you root privileges, which means that you have access to change anything and everything, and that can lead to unwanted consequences at times. So be careful if some code online is suggesting that you use sudo. There are times it's absolutely necessary, but then try and avoid it so that you don't make any changes that you don't want to do. But yeah, that's basically what we had for cron jobs. There's some extra learning resources that if you want to go through, you can. But yeah, that's all I got. Do you guys have any questions, concerns, anything that wasn't 100% clear?
My only suggestion is maybe they need to understand a little bit like more editors. Maybe like if they don't feel like comfortable with B, maybe just put a section in Nano because it's more what the normal user is more comfortable using, or Beam that is a little more friendly and it has like encoding. I don't know. That would be my only suggestion, but besides that, I think it was pretty good.
Yeah, so that's a good idea. Yeah, we could do a basic text editors section on this with just
yeah, because if they're gonna have to SSH, they need to have a text editing, like unless they do Sublime and they connect it somehow or whatever.
Yeah, you can do RMate on Sublime, but what I was going to point out was that one of the reasons I didn't go into that is every server you SSH into might not have Nano installed, might not have Sublime installed, or the text editor that you're most comfortable with present there. Nano is very common. You'll almost find it on any Unix system, but I've seen instances where it doesn't exist.
Oh, yeah, of course.
But you're right. We should add in a basic text editor section as well as just how to get Nano up and running on your system if you wanted to.
Yeah. Okay.
Anything else? I guess that's it, Dr. Nelson.
Thanks, Rohit. I appreciate that. I hope that, I know that in some ways for many of you, this is in the weeds a little early. It's hard to know, again, which topics are first or last, but I think this is a really good overview so that as you go forward and you get introduced and you see a Tethys project, that you now have this also as a reference to come back to. Don't feel like you have to dominate running in a terminal window, right? And Alma, you brought it up. I mean, at some point you need to have a reason to be in there, right? Before you really learn how to do it. And this is, the idea of this was just to introduce you, begin to get you familiar, give you some references so that as you have that need in different projects, you'll be able to do it. Great job, Rohit. Thanks, everybody. We'll do this again on Thursday. I think Chris is going to come and talk about a little bit more about cloud virtual machines and review that session. So we'll see you then.
Well, before you go off, I'm looking forward to the upcoming VI versus EMAC wars when you do the editor thing.
I'm gonna try and not do either one of them. We're going at him.
Atom is amazing.